The DRDO Airborne Early Warning and Control System is a project of India's Defence Research and Development Organisation to develop an airborne, early warning and control system for the Indian Air Force. Development history. In 2003, the Indian Air Force and Defence Research and Development Organisation carried out a joint study of the system-level requirements and feasibility of development for an airborne early warning and control system. The government then approved the project for the development of the Aew&Cs system by DRDO. Primary responsibility for the project was with DRDO's Bengaluru-based Centre for Airborne Systems, which led the design, system integration and testing of the system. LRDE was responsible for the design of the radar array. Defense Electronics Application Laboratory, based in Dehradun, was responsible for the data link and communication systems for Aew and Aew&Cs. The DRDO Aew&Cs program aims to deliver 3 radar-equipped surveillance aircraft to the Indian Air Force. The aircraft platform selected was the Embraer ERJ-145. 3 ERJ-145 were procured from Embraer at a cost of US $300 million, including the contracted modifications to the airframe. The project goal was to deploy these Aew and Aew&C aircraft by 2013. India's sole previous effort to develop an Aew&C system was the Airborne surveillance platform, but the program, codenamed Aerovate, was ended after the only testbed crashed. The Aew and Aew&C project aimed to supplement the larger and more capable LW2090 Aew&Cs acquired by the IAF from Israel. 3 LW2090 systems have been ordered, with follow-on orders of 3 more expected in 2010. Apart from providing the IAF with a cheaper and hence more flexible Aew and Aew&C platform as a backup to its more capable LW2090 class systems, the DRDO Aew and Aew&C project aimed to develop the domestic ability to design and operationalize airborne surveillance platforms. The delivery of 6 additional systems ordered in October 2010 is to begin from 2015. In June 2010, it was reported that the Indian Air Force is said to be looking at acquiring up to 20 additional systems. In addition to the existing systems on order, partners, the responsibility between various DRDO laboratories is split as follows: LRDE, primary radar, DEAL, communication systems and data link, DARE, self-protection suite, electronic support measurement 2, DLRL, communications support measures, CABS, IFF and AMP, overall program management, integration and development of the data handling system, displaced mission computers AL. Various Indian private sector firms are involved in the program. National Aerospace Laboratories contributed to the aerodynamic studies of the antenna array and flight modeling of the entire Aew&Cs platform. Design: 2 radiating planar arrays assembled back-to-back and mounted on top of the fuselage in an active antenna array unit will provide 240 degrees coverage. Like RI, the Aew was configured to compactly house 10 times 2 antenna array panels, 160 transmit-receive 10 times 2 antenna array panels, 160 transmit-receive multi-modules dividers, beam forming units, beam control units, power supply units and related electronic devices including cables and connectors. This has been achieved through an innovative and iterative process to arrive at the Aew with minimal dimensions and optimum mass properties. A unique feature of this Indian TRMM design is that 8 trans-receive modules are combined compactly to form a single TRMM RMM, thus facilitating high-density installation of 160 of them in the AAAU to power the surveillance radar. Additionally, the aircraft has other mission capabilities like identification, friend-to-foe, electronic and communications support measures, C-band line of sight and Ku-band SATCOM data links, etc. Similar to those on the Aew&Cs and Caew systems. The important modes of operation of the primary radar system are the surface surveillance and the air surveillance. The sensor has the abilities to search, track while scan, priority tracking, high-performance tracking, etc. In priority tracking, the targets will be placed in full truck mode even if these cross the primary surveillance area. In high-performance tracking, additional measurements will be made to improve the tracking accuracy. Utilizing active aperture technology, the radar provides a fast-beam agile system that can operate in several modes concurrently. Interoperability with Aew&Cs, other Aew&C aircraft, fighters and ground exploitation stations is ensured using the data links with voice and data channels. The aircraft cabin houses 5 operator workstations to adequately meet requirements of the operational mission tasks. And air-to-air refueling system enables extended operations at times of need. The endurance of the platform aircraft is about 9 hours with 1 air-to-air refueling capabilities. The Aew&Cs aircraft will have an active electronically scanned array primary radar with IFF. The system will also have ESM and CSM ability. Data links to network the Aew&Cs with fighters and ground-based control systems will also be provided, as will be the SATCOM. The aircraft will also have a comprehensive self-defense suite. The avionics suite will be linked via a data handling system controlled by mission computers. DRDO's public overview of the Aew&Cs aircraft stated, "The radar will have an extended range mode against fighter aircraft, and will consist of 2 back-to-back AESA arrays, with an additional dedicated IFF array. The ESM system will be able to track sources with a directional accuracy of 2 deg RMS and a frequency accuracy of 1 MHz. The ESM system will have complete 360-degree coverage in azimuth and have a database of up to 3,000 emitters against which threats will be scanned. Communication support measure system will analyze and record intercepted communications both in flight and post-flight. Self-protection suite will have a passive missile approach warning system, a radar warning receiver and countermeasures dispenses. The SPS will be integrated with the ESM and CSM suite. The aircraft will support in-flight refueling. The aircraft will have SATCOM and data links to pass on ESM, CSM and radar data to ground stations and data links to pass on target information to fighters. More than 40 other aircraft will be data linked together by the Aew&C aircraft. Status: the first round of modifications to the first EMB-145 fuselage for India's early warning aircraft were made in March 2011 in preparation for integration with the Indian-designed antenna. In June 2010, it was reported that the active array antenna unit developed by DRDO's Center for Airborne Systems was to be integrated into the modified EMB-145 aircraft. First test flight of the system was expected in early 2011. The first modified fuselage platform was handed over to DRDO by Embraer in February 2011. Ground and flight tests of the aircraft were to be followed by installation of radar and other equipment. The first fully modified EMB-145I aircraft with the antenna and its electronic payload made its maiden flight on 6 December 2011 at Embraer facilities at São José dos Campos in Brazil, with about 1,000 mission system components provided by CABS, DRDO. These included the critical item AESA radar antenna developed by DRDO and certified from ANAC, International Far Certification Agency, at São José dos Campos in Brazil. Some of the sensitive advanced systems were replaced with dummy equipment of equivalent size and weight. These were to be integrated later in India following flight certification. A 2-year certification period is expected. DRDO is expected to receive the next 2 aircraft platforms to start integration by mid-2012. Maiden flight of the second fully modified aircraft for the Indian Airborne Early Warning and Control System was held at 1930 IST on 4 April 2012, at the São José dos Campos in Brazil. The necessary mission systems and components, including the dummy AAAU, were successfully fitted on board Embraer EMB-145I aircraft. Embraer Defense and Security, on 16 August 2012, delivered the first EMB-145 Airborne Early Warning and Control class of aircraft to the Government of India, in a ceremony held at Embraer's headquarters in São José dos Campos, Brazil. The delivery follows successful completion of ground and flight tests of the aircraft, which met operational targets established by both Embraer and Centre for Airborne Systems of Defense Research and AMP Development Organization. Later on, the aircraft will be delivered to the Indian Air Force after integration of mission systems of DRDO by CABS in India. First delivery. The first fully modified aircraft for India's Airborne Early Warning and Control System landed on Indian soil at CABS at 22:10 hours, at Hull Airport, Wednesday night at the 22nd of August 2012. The acceptance of the aircraft was completed over a period of 15 days at Embraer facilities in Brazil, by a team from CABS, its work centers, CEMILAC, DGAUNIAF. The aircraft ferried with several mission system external components of DRDO, including the active electronically scanned array antenna with passive electronics fitted on the aircraft. The arrival of this aircraft marks the beginning of another phase of journey leading to the next major milestone of integration of the DRDO developed mission system, which will be followed by development flight trials in India beginning of 2013. It may be noted that this is the first aircraft delivered by Embraer, for which the contract was signed in 2008. The next aircraft is expected to arrive in December 2012. Future development. DRDO and the Bengaluru-based Centre for Airborne Systems have launched a new project to build larger and more capable AEW&Cs. Initially, 2 AEW&Cs aircraft will be developed, with 4 more to follow at a later stage. Clearances for the project were received from the government in January 2013.